My dear people, in this particular video, we are going to be looking at the dimensional homogeneity of few of the very common equations that we know of. Because if an equation is to be correct, it has to have dimensional homogeneity. Otherwise, the dimension in the left hand side of the equation should equal to the dimension in the right hand side of the equation. Yeah, well, let us just start, shall we? One of the very common and one of the most popular equations of all time is E equals mc square, where E is the energy, m mass, and c is the velocity of light. Okay, what is the dimension for the left hand side? Energy. For energy, we know that the dimension is m L square t power minus 2. Yeah, so let us see if this is the same dimension we get for the right hand side of the equation. So it is m c square. M is m for mass, velocity is L t power minus 1 whole square, so which is m L square t power minus 2. So m L square t power minus 2, which is the one for energy. So the left hand side equals to right hand side. So we can say that this particular equation is dimensionally homogeneous, or it is correct. Yeah, let us look at some of one more equation that we are so very aware of: potential energy. What do we know? Potential energy is mgh. Yeah, this is the one. So let us look at the left hand side of the equation, shall we? Potential energy or any energy, the equation is m L square t power minus 2. Now let us look at the right hand side of the equation and then see if it is true, shall we? Yeah, so mgh. So what are the dimensions for mgh? For mass, it is m times g. You might be like wondering, what is the dimension for g? G, my dear people, gravity is nothing but the acceleration due to gravity. So, what is the dimension for acceleration? It is L t power minus 2 times h is length. So, here, so if I write it, m L square t power minus 2, because L times L becomes L square. So m L square t power minus 2. So the left hand side equals to the right hand side. So we can say that the potential energy equation is dimensionally homogeneous, or that it is true. Okay, can you try for the kinetic energy equation? Kinetic energy equation, as you know, is half m v square. Yeah, half, my dear people, it does not have any dimension. So, well, you know what, let me do it for you. So energy left hand side equals kinetic energy is nothing but m L square t power minus 2. Yeah, so let us look at the right hand side. Right hand side is half m v square. Half does not have any dimension, so I can cancel this out. So I just have m and v square. Yeah, so m is mass is m times velocity is L t power minus 1 square, so which equals m L square t power minus 2. So ml power t power minus 2, ml power t power minus 2, I can say left hand side equals right hand side. So this equation is dimensionally homogeneous. Yeah. What other equation? I'm full of equations, Well, I have so many equations to discuss with you. Why don't we try this? Velocity equals square root of 2gh. Shall we try this? Huh? This would be so cool. Okay, now what does this really mean? Velocity equals square root of 2 times square root of g times square root of h. This does not have any dimension, so that's fine. So we can say this as gh power half. Yeah, that is what it means. So let us see what is the dimension for velocity. Lt power minus 1. Now let us look at the right hand side. Gravity, acceleration due to gravity is Lt power minus 2 times height is L power half, which is nothing but L squared t power minus 2 power half, which is nothing but half of, well, square root of 2 is 1, again t power minus 1. So L power 1 t power minus 1. The right hand side equals the left hand side. So we can say that this equation is also dimensionally homogeneous. Yeah. It is true. It is true. Yeah. Okay, let us look at one more equation. Let us look at equation of motion, shall we? S equals ut plus half at square. Okay, in this equation, to prove that it is dimensionally homogeneous or it is true, we have to have the same dimension for the term here, the same dimension here, and the same dimension. So if we can say the dimension for s equals to the dimension for u times t equals to the dimension for at square, then it means that the equation is true or it is dimensionally homogeneous. Yeah. Okay, what is the dimension for s? S is nothing but displacement, so it is L. So if we can prove that this term ut has the same dimension, otherwise the dimension of ut is L and also half at square is L, then bravo. So what is the dimension for ut? ut u is nothing but velocity, so L t power minus 1 times t here is nothing but time t, which is nothing but L t power minus 1 plus 1 is nothing but L t power 0, which means t anything power 0 is 1, so it is just L. So so ut is also L. But okay, again, let us not get too excited. Let us check if at square also gives the same dimension L, shall we? Yeah. Okay, at square equals acceleration. A is acceleration, which is L t power minus 2 times t square. T is nothing but time, so t square just nothing but L t power minus 2 plus 2, so L t power 0, which is nothing but L. Woo-hoo-hoo. So we can see that the dimension, if I write it in the dimension form, if I write equation 1 in dimensional form, L equals L plus L. Yeah. Some people even go to the extent of saying L equals 2L. L plus L is 2L. Yeah. 2 does not have any dimension. So L equals L. So they say this is dimensionally homogeneous. Yeah. Okay. People, I would like you to try. Yeah. And prove that the equations V equals U plus AT. Yeah. And the equation F equals MA, where M is the mass, A is acceleration, F is force, pressure equals force divided by area, and also P equals rho GH. What else? Volumetric flow rate. Yeah, V dot equals, what is the formula? Area times velocity. C here is velocity. Yeah, and mass flow rate, M dot equals, what is it? Volumetric flow rate times density. Yeah, can you please prove 1 2 3 4 5 6 equations as dimensionally homogeneous. Yeah, prove they are dimensionally homogeneous. Gone.